This is Mrs. Ford, and I am going to go over classwork for section 6.3, the first part, vectors in the plane. So exercise 1 and 2 is asking you to show that vector u is equal to the vector v. And remember, in order for two vectors to be equal, two things have to happen. They have to have the same magnitude. In other words, they have to be the same length or have the same speed. And the second thing is they have to be going in the same direction, so the angle has to be the same. So the first thing I'm going to do is I'm going to check the length or the magnitude of both. So I'm going to find the magnitude of u. Remember to find the magnitude of u. I take the 2 points and I find the difference between the x's. So 6 minus 2 squared plus 5 minus 4 squared. And when I do that, I end up with the square root of 17. When I find the magnitude of v, remember it's starting at origin 0, 0, so to find the magnitude of that, I would do 4 squared plus 1 squared, and I get the square root of 17. So the magnitudes are the same. The next thing I'm going to do is check the direction. To find the direction, I take the tangent of b over a. So in order to do that, first I'm going to put this in composite form. I should have done it first. But I'm going to do the inverse tangent. When I do that, I'll do 5 minus 4 over 6 minus 2, which will end up being the inverse tangent of 1/4. Over here, when I go to find the angle, the inverse tangent of the b over a. So it's the same thing, and I could go ahead and find that angle if I wanted to, and the angle ends up being 14 degrees. When I find that. So the angle is the same. I can do this on a smartboard. You can't do this at home. If I take U and I sketch U, and I just take that angle, and I pick it up, and I lay it right on top of V. That's one way it could have done. The other way is I could have found the component form with this. So that would have been 6 minus 2, and then 5 minus 4. And when I do that, I get 4, 1, which is the same as that would occur there. So that's another way I could have found that those two vectors are the same. They have the same component form. Same magnitude, same angle direction. Find the component form and the magnitude of the vector. So here, my initial side is at the origin, which is 0, 0, which means that this endpoint, this terminal point, is the vector in the component form. If you don't believe me, you could take 4 minus 0, 3 minus 0, and you're going to end up with that 4, 3. So that's the component form. Then the next thing I'm going to do is find the magnitude. So a lot of you can find the magnitude of v. If I have the component form, I'm just going to take the square root of a squared plus b squared. So that's 16 plus 9, square root of 25. So the magnitude is 5. And that's all I had to do for number 3, was find the component form and the magnitude. Number 7, same thing, once we find the component form and the magnitude. So to find the component form, we're going to do the difference of the x's, and then the difference of the y's. Remember, it's terminal minus initial, and it doesn't really matter with the x's because they're the same, but it does matter with the y's. So I'm going to take 3 minus -2. The direction matters, so you need to make sure that you're always taking terminal minus initial. Terminal minus initial. So I'm going to have 0, 5. That's my component form. Then to find the magnitude of that, I'm going to do the square root of 0 squared plus 5 squared. Again, a lot easier to find the magnitude once you have that component form. And that's going to be the square root of 5 squared, which will just be 5. So the magnitude is 5. Next one, it tells me the terminal point is 0, -7 halves. The initial point is 7 halves 0. So to find the component form, I take the terminal minus the initial. So this will be 0 minus 7 halves. And then the x will be -7 halves minus, I said x is on the minus 0. So this will be end up being, what's the point? It'll be end up being -7 halves and -7 halves. So that is the component form. To find the magnitude, I'm going to call it. I'm going to do the square root of -7 halves squared plus -7 halves squared. Remember when you square that, it's going to be composite. 29 over 4. So that's going to end up being 98 over 4. I'm taking the square root, so I'm thinking the square root of 98 squared 4. I know 49 will go in there, so 7 times the square root of 2 over 2. And that is going to be my magnitude. And 13 to 18, it says use a figure to sketch the graph of a specified vector. So 13 wants the opposite of V. So right now V is going up into the first quadrant. So the opposite vector is going to sort of flip across the origin. So it's going to come down here, and that's going to be the opposite of V. Now U minus V, since I already have minus V, I'm going to use that. U minus V would be putting these two vectors together. So let's say I take, so this is my U here. So, and there's the opposite of V. So if I put U minus V, or U plus negative V, I would end up with that. I just took the opposite of V, and there's U. So it's like I'm taking U minus V. That is the same as that. And so to find the vector that's the resulting vector, I would start at the origin, and end at this point here. So this blue line is U minus V. That's the vector. Kind of have to combine it together. In 25, you want to find U one. You want to find U plus V, U minus V, 2V minus 3V, and V plus 4V. So 27 is already written in component form. So for A, I want to do U plus V. So I'm going to take negative 6. U plus V. So negative 6 plus 2 and negative 8 plus 4. It's the best way for me to write that. And then I end up with negative 4, negative 4. For part B, it wants U minus V. So I'm going to take U, which is negative 6, minus the V, which is 2, negative 8 minus 4. And when I do that, I will have negative 8 and negative 12. The next one is going to be 2U minus 3V. So I'm going to take 2 times that negative 6, negative 8. So negative 12, negative 16, and then minus the 3V. So I'm going to make this plus and distribute a negative 3, if you don't mind. Make this negative 12, oh no, 3, negative 6, and then negative 12. And when I add those, I'm taking negative 12 plus negative 6, and then negative 18, negative 16, negative 12, negative 20. And that's my final. I really don't like the way I did that one, so I'm not going to do it probably again. The next one, D, is D wants V plus 4U. So notice that they changed the order of U and V. So it's going to go 2, 4 first, and then 4 times the other one. So it's going to go 2, 4 first, plus 4 times that negative 6, negative 8. So I'm going to have 2 plus a negative 24, and then 4 plus a negative 32. And when I do that, I end up with negative 22. And that is the answer to A, B, C, and D. Do number 29, it's written in linear combination form, and I'm going to want to write it in component form first. And I'm going to, I don't know that you have to, but I'm going to. You don't have to, I guess, because I'm going to have to write every answer back in linear combination form. But I'm going to think of U as 1, 1, and I'm going to think of V as 2, negative 3. I just think it's easier to work without the I and the J. So then for A, I'm going to do U plus V. So that's going to be 1 plus 2, and then 1 plus a negative 3. And then it ends up being 3, negative 2. Now, Since it started off as a linear combination, it has to end as a linear combination. So we're going to write this as 3i minus 2j. To do part B, I'm going to do u minus v. So I'm subtracting. So when I subtract, I'm going to take 1 minus 2 and 1 minus negative 3. So I'm going to have negative 1, 4, and I'm going to write that as negative I plus 4j. For C, that's going to be 2u minus 3v. So 2 times that 1, 1, minus 3 times that 2, negative 3. So that'll be 2 minus 6, and then 2 plus 9. So I'm going to end up with negative 4 and 11. That's going to be negative 4i plus 11. And the last one, D, remember this one, they're switching orders, don't let them trick you. And it's V plus 4U. So V was that 2 negative 3 plus 4 times that 1, 1. So this is 2 plus 4 and negative 3 plus 4. This ends up being 6, 1, which I'll write as 6i plus 1j. And it's 1 in there, but I didn't, so I didn't. So that's how you do those. Just make sure you keep track. And once again, if it's starts in linear combination, then your final answer has to be in linear combination. You have to give it back in the same format. So the next one says, use the vectors to write a vector in terms of the other two. So I want W. And so if I look at W, it looks like I took U, and then at the end of U, I put V there. So it looks like that's just going to be U plus V. And it's a simple thing. Okay, numbers 35 to 44, find a unit vector in the direction of the given vector. So a unit vector is a vector that has a magnitude of 1. And the reason why that's so important is because eventually we're going to bring back our unit circle, which was a unit circle that had a radius of 1, which means it would have a magnitude of 1. So we want to be good at rewriting these so we can place them back onto our unit circle. So the first thing I'm going to have to do is I want to find out how long this vector is to begin with. So I want to find out what the magnitude of the vector is first. So I'm going to find the magnitude of vector v, and now I'm going to do that by taking the square root of negative 24 squared plus negative 7 squared, and make sure when you're doing squared and it's negative that you put in parentheses or you know that it's positive. Just make sure you know that. And this ends up being the square root of 625, which is 25. So right now the magnitude of this vector is 25 units. I want to knock it down to 1 unit. So the easiest thing to do is divide it by 25. So if I want to divide this magnitude by 25, then what that means is I'm going to take both means I'm going to take both angles, I'm going to take both dimensions, and I'm going to divide them by 25. So the unit vector V is going to have the same direction. So this negative 24 and this negative 7 sends it in the same direction. But by dividing both of them by 25, it makes sure that the magnitude is only 1. Because if I do this, if I go to find the magnitude of this, since I'm dividing them both by 25, it means I'm going to divide this by 25, which means the magnitude is 1. So that's the logic behind it. So the next one, I want to find a unit vector in the same direction. So right now, the one is 1, negative 2. So to find the magnitude of W, I'm going to do the square root of 1 squared plus negative 2 squared. And that ends up being the square root of 5. I cannot simplify that. So to find the unit vector, I'm going to take both coordinates, so that 1 and that negative 2, and I'm going to divide it by the square root of 5. But we know we can't leave it like that because we have to rationalize our denominator, and we remember this from the trick, so we're going to multiply by square root of 5, square root of 5. So when I do that, I end up with the square root of 5 over 5, and negative 2 times the square root of 5 over 5. So that is the unit vector, but I start off in a linear combination, which means I have to end in linear combination. So I'm going to write the square root of 5 over 5I minus 2 times the square root of 5 over 5j. And that is my unit vector in linear combination form, which is the form that it's given to me in. So I'm going to end this. Okay, the next one, number 45. Find the vector v with the given magnitude in the same direction. So it's the same idea of what we did before. I don't know what the magnitude of u is right now, so we're going to find the magnitude of u. Then I'm going to knock it down so it has a magnitude of 1, because then it will be a unit vector. And then because of the magnitude of 8, I'm just going to multiply it by 8. So there's quite a few steps here. So the first thing I'm going to do is find the magnitude of u. This is 45. So we're going to do the square root of 5 squared plus 6 squared. And when I do that, I end up with the square root of 61. Then to find the unit vector, I'm going to take the same order of pair that I had for u. So the unit vector, and we'll just call the unit vector u, is going to be 5 and 6. Same thing, but I'm going to divide by the magnitude. So I'm going to divide by the square root of 61. Have to rationalize. So I'm going to have 5 times the square root of 61 over 61. 6 times the square root of 61 over 61. So now this has a magnitude. The magnitude of this, I popped up and thought something different. The magnitude is going to be 1. Well, I wanted to have a magnitude of 8. So if I want 1 to equal 8, I'm just going to multiply by 8, which means I'm going to take this vector that I just found and multiply that by 8. So I'm going to have an 8 over 1. So 8 times 5 will be 40 times the square root of 61 over 61. Nothing simplifies. And then 8 times 6 will be 48 times the square root of 61 over 61. And this is my final answer. And it was given to me in component form, so I'm going to answer in component form. So that is my final answer for that one. The next one, doing the same process, I'm going to find the magnitude of u. So the magnitude of u, well, I should probably write that in component form first. It's just a j. So it's 5j, which means I can think of that as 0I plus 5j. So my component form will be 0, 5. So to find the magnitude, I'm going to take the square root of 0 squared plus 5 squared, which would just be 5. And that should make sense to you, because if I were to graph this, I'm just going to graph 1, 2, 3, 4, 5. It's just going to be a vector that goes like that. So it has a length of 5. That makes sense to me. To find the unit vector, I'm going to take that 0, 5, and I'm going to divide both by 5. So I'm still going to have 0 and 5 divided by 5 is 1, which should not make sense to you, because now I'm knocking this down to the has magnitude of 1. So it's a unit vector. I want to have a magnitude of 4, so I'm just going to multiply this by 4. So I'm going to end with 0, 4. Start off in linear combination, need to end in linear combination. So this will be 0I plus 4j, or I can just write 4j. And that's all I have to do correctly. It's not that bad. Okay, the next one, it says the initial and terminal points of a vector are given. Write the vector as a linear combination of student I and j. So remember to find, I'm going to put it in component form first. And define component form, remember to always do terminal minus initial. Terminal minus initial, so I'm going to do 4 minus -3, and then 5 minus 1. Component form would have those brackets, so I'm going to end up with 7, 4. And I like vector combination student and vector shiny. The book, for some reason, actually puts it in linear combination. here? Because it says write the vectors in linear combination. That's why. Here's a linear combination. Okay, the next one, I am going to do same process, terminal minus initial. So this is my terminal, 0 minus -6, bracket, 1 minus 4. So I'm going to end up with 6, -3. And then the linear combination is going to be 6i. 6i minus 3j. Okay, and that's that. Okay, in exercise 55, it says write the component form V and sketch the specified vector by the operations given. So this one, they're telling me that U is 2i minus j, so I'm going to think of that as 2, -1. W is I plus 2j, so I'm going to think of it as 1, 2. So those are my two component forms of the linear combinations. V wants, so I want V to be 1/2 3 times U, so this is going to be -6, +6, -3, plus W, which is 1, 2. So then when I do that, I end up with 1/2, and then this is 6 plus 1, -3 plus 2. So that's 7, so 7 halves, -1/2. So it would be 7 halves I minus 1/2 j. I think that's the easy part. Now they wanted me to sketch this. So here it goes. So U, I'm going to do U is going to be red. 2, -1. 1, 2, -1. This is U. That red line is U. Then let's switch to blue for W, which is 1, 2, 1, 2. That is W. I should put my terminal signs on there. I should like that. So there is my arrow to show my direction, because direction matters. So when it wants, so I'm going to do inside the parentheses. Oh, actually, if I just shoot it in, no, I think it's in 3U. So this one U is, so if I take this and I do 3 of them. So I'm going to take this and do 3 and 1. So that's 3 of them. Yes, that's 3U. And then this is the W. So if I take that W and I add it to the end, and add to the end of my 3U, going from the origin, I go from here to here. So this black line is 3U plus W, and then the half means I'm going to take that and half of this. I'm going to end up with half of this. About there. About half of it, which does sort of look like 7 halves and 1 half. So that's the visual drawing. And that's kind of hard. You don't have a smart board, but that's kind of what they want to do. Again, that's one way of doing it. Another way is I could have done distributed 1 half and done 3 halves and 1 half. And then add those two together. Doesn't matter. All right, now I'm doing 60. So 60, 2U minus 2W. So 2 times 2, -1, minus 2 times 1, 2. If I have a minus, I like to distribute the negative sign and make it plus. To me, it just makes life easier. This is 4, -2. And we think of this as plus -2, -4. So this is 4 plus -2, -2 minus 4. So I end up with 2, -6. Linear combination, 2i minus 6j. Now let's start drawing that picture again. So U is going to be 2, -1. that's in red. 2, -1, that's 2. And then B is 1, 2. So if I did right, that's U and that's W, and now I want to do 2U. So the smartboard, I can just draw it again. You can have it back. And then it wants minus 2W. So this is W right now. W right now. So the negative would put it down here, in the opposite direction. And 2 is already make those go twice. So that's that. So now I'm going to take this whole, this is negative 2 to W. I'm going to take that and add it to my 2U. So that's going to go here. And then from my origin, I'm going to go from here to here. And close, it should be 2, -6, and I'm 1, 2, 3. I'm pretty close. If I make a big dot, that is 2, -6. So that's the visual representation of what we did. And that ends the 6-3A homework. I hope this helps. If you have any questions, let me know.